Alright, boys and girls, this is a video about vectors. I told Josephine she's going to be in the video, so here's Josephine. She'll be working with me today. Vector, if you watch Despicable Me, he says a vector is a line that has direction and magnitude. What that means is that the direction that this is going, where the arrow is pointing is the direction, and how long the arrow is going to be whether we're talking about speed or we're talking about anything else like that. So if I had a vector that was like this would be less powerful or have less magnitude of this line. And if the arrow is going this way, then that's again the direction, and you can see that if these were using speed, that this one would be faster than these lines right here. Now, vectors can be seen in a lot of everyday things. They can be seen, even as far as when you look at the weather and you look at the wind speed. It might say that the wind is moving southeast at a rate of 15 miles per hour. You're going to see an arrow right there in the newspaper or on the newscast. That's a vector. Now, vectors can be, what you have to do is sometimes you have to take two vectors and you have to find a resultant. So an example of that is there are two ways. If I have two vectors, here's vector A and vector B, and you can see they're going in totally opposite directions. And when you combine them or add them together, you get what is called a resultant. And a resultant is just what results from these two vectors. So for instance, if I had a plane flying this way and I had wind going this way, where would the plane, how would it affect the plane? In this case, the plane, this vector would have been a lot longer though, because the speed of the airplane is going to be a lot greater than the speed of the wind. So to put them together, there's two methods. The first method is called the head-to-tail method. And the head-to-tail method is quite easy. You take one of the vectors and you have to draw it in the same direction that the other one goes, and you're supposed to measure it so it looks exactly the same as that one. And then you take the second vector and you put the tail of vector B where the head of vector A was. So it looks something like this. Now, the resultant is if you take the very beginning and connect it to the very end, this vector right here would be our resultant. How long this vector is would tell us the magnitude or the power or the speed or whatever we're trying to find out, but also the direction is important. That direction is where your final vector is going to be going. It's a little easier to explain when we talk about word problems, but that's the head-to-tail method. Now let me show you the second method, which I prefer, but you could use either one, which is called the parallelogram method. And parallelogram method, we're going to take vector A, and I'm going to draw it in the same direction that it was in the first one. And then I'm going to take vector B, but instead of taking vector B and connecting the head to the tail, I'm going to connect the tail of vector B to the tail of vector A. And it's going to look something like this. Now, what your job is to make a parallelogram based on those vectors. So a parallelogram is I'm going to make a line parallel and equal to this one, which will look something like this. And then this one would be like actually it would be about right there. And if you connect make a parallelogram from where the two tails started to where the vectors met over here, this right here would be your resultant. And I know I didn't do it perfectly, but if you look at the two resultants, the one from this problem and from this problem, they look exactly the same, and they should be, because both methods get you the same answer. Now, let's figure out in a word problem how this works. So here are three examples of where you might find vectors, and you could have two cars crashing into each other, because that's a way that you could kind of find out where would the cars end up where would the force be and how much force would be on the cars after they crash. Another thing is if you're swimming at a certain speed but you're going against the current. And last, anything, with in the air, especially like things like hot air balloons or airplanes, you have to factor in where the wind's going. So let's do a problem against swimming against the current. So let's say, for example, you are swimming exactly due north, and you're swimming at, say, 6 miles per hour. And the current of the water is exactly going due east, which would mean it's exactly east. And we're going to make that, it's a long current, so we're going to say it's 10 miles per hour. So you would imagine that you're not going to be swimming when it's all said and done exactly north. The current's going to push you east a great deal. Well, to find out how many miles you'll actually be swimming and the direction you'll be swimming in, let's use the parallelogram method. So I'm going to take the 6 mile per hour vector, the actual your speed. I'm going to write your speed so that we remember that. And the actual current, and I'm going to connect that to the tail. And then I'm going to go ahead and put in the numbers, 6 miles per hour, 10 miles per hour. Then what I'm going to do is I'm going to make a parallelogram. And finally, draw the resultant. And the resultant is exactly the direction you would be swimming in and the speed you actually would be going. Now, the nice thing here is because we were going north and east, right here, the very original problem, there was a right angle between them. Well, in any parallelogram, we have to remember that the supplementary angles are going to be, the adjacent angles, or the angles that are right next to each other, are going to be supplementary. So if this one's 90, that means this one has to be 90. And since we have a parallelogram, because this side is 10, the opposite side is also 10. Well, now we can actually find out this vector because we have a triangle. Now, you can use, in this case, you could actually use the Pythagorean theorem. You could use the law of sines. You could even use the law of cosines to find out what x is. I'm going to go ahead and use the Pythagorean theorem. 6 squared plus 10 squared would get us 136. X squared equals 136. So x is going to equal, I could break this down into, well, actually we're going to go ahead and we'll just say for now, we're going to round it. So you could simplify that radical, but x is going to be root 136. And root 136 is about 11.66. So your speed that you're actually going to be going is about 11.6, and this vector shows you the direction you're actually going to be swimming in. Well, let's do another one of those problems just so you kind of get the idea. Let's say that someone was pulling on something at a 43-degree angle as someone else was pulling on that same thing. And the force, there in science you learn that there is actually units of force, but we're just going to give them a random generic number. We're going to say that the force that this person is pulling on would be, say, 10. And the force that this person's pulling on is 26. So the actual object is not going to go in the direction that they're pulling. The actual object is going to move in where the resultant is. So we're going to make a parallelogram. And before I draw my resultant, let's remember that if this is 43, this angle right here is going to be the supplement of 43. So let me do 180 minus 43, which gets you 137. So we got this angle is 137. That's important because we're going to be using that angle. Then let me draw the resultant. So that's going to be where the object is going and the force applied on the object. So let me go ahead and erase this 43 because we didn't cut it in half. We don't know how much each one is. So to find out what x is, I'm going to go ahead and remember this is a parallelogram. So if this is 26, this is also 26. And now, to find out what x is, I can use the law of cosines. I'm not going to do the whole thing for you because we did that in the last chapter. But you can say x squared equals 10 squared plus 26 squared minus 2 times 26 times 10, so 260, then times cosine 137. So if you go ahead and solve this, you're going to actually get what x is, what that vector, what the force is on that vector. Let's pretend for a second that you get, Dylan, what do you get? 34.204. Okay, so we're going to say it's about 34, and you're going to go ahead and save that number. Now the other thing you can say is, what angle, what is the resultant going in respect or in regard to the person pulling it 10, whatever that number is. So what I'm asking you is, at what angle is this actually going compared to this guy? So I'm asking you that theta. Well, once you get this is about 34, now to find this angle, I can actually use the law of sines. But that's how you work with vectors.